Hello. Welcome to Algebra 2, Mrs. Cran's video number 3, Graphing Logs, section 7.4 in the book. I plan to post this on Thursday, April 2nd. All right, but before we go to graph logs, first we're going to go back and review one exponential. All right, a, b to the x minus 2 minus 3. B is less than 1. So is this growth or decay? Will it be going up or down? Well, it is decay. This is a 75% decrease. All right, so we're going to be graphing this. It'll be going down. All right, the minus 3 on the end means 3 down for the HA, which is the horizontal asymptote. That will be down at y equals -3. Okay? Go down, -3, draw in the HA, horizontal asymptote. This is the line that the graph will approach, head towards, but never quite get to. All right, our domain, x equals all reals. We're going to pick any x we want. Our range will be y greater than the HA number, -3. Okay, this 3 down is very important. The -2 with the x is opposite. It means 2 to the right. Now that won't affect as much the way the graph looks, okay? But the points are going to be more over on the right-hand side than the left. Okay, but it will affect the x's we pick. Because normally I like to start with 0 if I can. But look what happens. If we go 2 times 1/4, 0 minus 2 is -2 power minus 3. That means 2 and then reciprocal times 4 squared minus 3. That's going to give me 32 minus 3. I don't think I want to graph that. That is too high. It's not going to fit in my graph. So forget it. I'm not going to go with 0. How about 1? All right. 2 times 1/4 to the 1 minus 2, -1 power minus 3. That'll be 2 times 4 to the first. 8 minus 3 equals 5. Okay, that'll fit on here nicely. All right. So if you pick an x that you're getting a number that's just not going to fit in the graph, pick something different. Or if you're forced, then you have to number your y by maybe 2s or 4s. Okay, but this I think we can fit on here. All right, now we will go with 2. That's 2 times 1/4 to the 2 minus 2, 0 power minus 3. That's 2 times 1, 1. 2 times 1 minus 3. We're going to get -1. Right? Perfect. So 2, -1. Now how about 3? That'll be 2 times 1/4 to the 3 minus 2, first power minus 3. 2 times a 4 is a half minus 3. That gives me -2 and a half. 3, this is where it's headed towards -3, but we'll never get there. All right, 3 points is good enough. 4 is a little better, but 3 points will allow us to graph this. All right, here's the exponential decay. All right, going down, then we'll draw on this tail end. 2 arrows on your graph. Exponential decrease. Okay, that's the review. Now we'll go to graphing logs. Okay, this we're going to talk about some steps. All right. First step is to isolate the log, which is sometimes already done. I have log, I have base, I have argument. Isolated. Now if there was like a 3 in front, I would divide by 3. If there was a +2 in the end, I would subtract 2. But this one's done. All right. Second step, change over to exponential form. Okay. Choose the base, raise it up to the y power equals x. Then we're going to solve for x. But third step is done, just like the first step. So we're ready to go. Are you ready? Hopefully. Wake up. All right. Are we ready? All right. Now, how do I do this? Okay. It's going to be different. You have a domain and range, but you're going to have a vertical asymptote, a vertical line that the graph approaches but never reaches. That's an asymptote, right? This is not shifted any way, up, down, left, or right. all right? If you don't shift left or right, you're going to have a vertical asymptote at the line x equals 0, which is the y-axis, all right? The VA, vertical asymptote, at 0, all right? That directly gives me my domain. X has to be greater than 0, okay? Now, the entire graph's going to be over here, all right? Now, we're going to get some points. This is very, very unusual, all right? But since it's solved for x, not for y, we are actually going to pick y numbers, all right? Any y we want. When you get to pick any y you want, the range this time is all real numbers. Anything. All right, so let's try a 0, 2 to the 0 power. Anything to 0 power is 1. Then we try a 1, 2 to the first, 2. 2, 2 squared, 4. 3, 2 cubed. I can hear it. What are you saying there? 8, exactly. How about negatives? I can pick anything I want. Negative 1. 2 to the negative 1 is 1 over 2 to the first, 1/2. Negative 2. 2 to the negative 2 is 1 over 2 squared, 4. Look at that. I got a whole bunch of points, more than enough. All right, so we have 1, 0, 2, 1, 4, 2, 5, 6, 7, 8, 3. Here's the top half of my log. Flattens out here. Then I have 1/2, negative 1. 1/4, negative 2. This is my tail end now. Headed towards a vertical line of 0, but never hitting 0. Okay? So this is a typical log curve. Okay? All right. Let's try another one with a shift on the back. Number 3. All right. First step, isolate the log. Done. Second step, change over to exponential form. 3 is my base. To the y power equals the argument, x minus 1. Now we're going to solve for x. Add 1. X equals 3 to the y power plus 1 on the end. Okay? Now, before I get my points, I'll talk about domain, range, vertical asymptote VA. All right? The vertical asymptote, all right, will deal with the number, if there is one, with the x in the argument. Okay? Last time it was just x. Okay? 0 VA. This time x minus 1. All right? This is the shift we're used to doing. It's opposite. Okay? So we're going to shift this 1, not to the negative, 1 to the right. Okay? All right? That makes my VA now become x equals 1. My domain will be x greater than 1. I can draw that in. This frames my graph. I can do it first or I can do it last, but don't forget to do it, and if you can do it in color, that would be great. All right? Range, do you remember? All real numbers. We're going to pick our y's, plug them in, solve for x. Okay? Now let's see. Will 0 work this time? 3 to the 0 plus 1. Anything 0 power is 1. 1 plus 1, 2. Nice. First point. 2, 0. All right, let's pick y's. Remember, you're picking y's. This is very unusual. Normally you're picking x's. This time we're picking y's on the log. Okay? So now I'm picking 1, 3 to the first, plus 1. That gives us 4. What about 2? Will I make it? 3 squared plus 1 gives me 10. That should do it. What if I went negative? 3 to the negative 1 plus 1. What is that? 3 to the negative 1/3 plus 1. That gives me 1 1/3. All right, let's see how this works here. All right, we have 2, 0. We have 4, 1. 5, 6, 7, 8, 9, 10, 2. Then I have 1 1/3, -1. All right, so here's the top half. Then we have the tail end with x heading towards 1 but never hitting it. Okay. Translation 1 to the right gives you VA of 1. Domain x greater than 1, y can be anything. All right, one more example. Here we have y equals log base 6 of x plus 1. Right? The plus 1's on the end. It's not with the x, okay? So that means my VA is at 0, like normal. Domain x greater than 0. Now I'm back to 0, okay? All right. Range again for all these logs. Y equals all real numbers. This plus 2 on the end is not opposite. This means 2 up. Okay? So this one's going to be up higher. It's not going to affect the vertical asymptote. Okay? All right. Now, I'm not ready to go to exponential form first. Isolate the log. So I have to isolate. Isolate the log. Opposite of add 2, subtract 2. Y minus 2 equals log base 6 of x. Okay? Then change it over to exponential form. The base this time is 6 raised up to whatever's on the other side, which is y minus 2 equals x. Okay? Now it's already solved for x. Here I had to add 1. Here it's done. Ready to go. Don't pick x's, pick your y's. All right. So can I pick 0? Well, I get 6 to the 0 and -2. That's 1 over 6 squared, 1 over 36. Well, maybe not that great. How about 1? That's 6 to the -1. 1 6. Well, that's a little better. How about 2? That's 6 to the 0. Anything 0 plus 1. All right. 3. You get 6 to the first. 6. I go 4. All right. 4 minus 2. I get 6 squared, 36. All right. Well, I know I can get these 3 on. All right. I've got 1 6 1. 1 2. All right. 3, let's see, 3 4 5 6 3. 3 points are good enough. 4 are better, but I can't fit those guys on there, so this looks good enough. All right, and there we go. This is graphing logs. This is the general shape of logs. Okay, they could be stretched a little higher, could be compressed, and then they're really, really narrow. But this is about it. All right. Good luck, and please, again, send me any questions via email or classroom. All right, thank you. Have a good one.